students, welcome back to the series of lectures of Intermediate 1B. Today we are going to discuss the differentiation chapter 9C exercise, in that section 3 problems, right? Now section 2 and section 1 you can just click on the I button and get it notified. Those were the previous classes which I have completed. So you can also check the playlist for the differentiation chapter. Right, let's quickly start the 9C exercise. I have noted down here, find the derivatives of the following functions. That's the question given, and in that the first bit. Now here there are 4 bits. I'll be doing for you any of the 2 bits, then the remaining 2 bits you have to practice, because in maths if you yourself do practice it, you will be getting it. Okay, so 2 of them I'll give for the model and 2 you can do it for yourself. Now here when you are seeing this, given y function already, sin x raised to the power of log x plus x raised to the power of sin x. Clearly there is an exponents, right? When exponents are involved, we have to go for the logarithms, right? Here I'll be applying log both sides, but before that I'll take this function as y1. Let y1 be the first function, this function, that is sin x raised to the power of log x, and I'll take this function as y2, x raised to the power of sin x. So that what does our y become? Here our y will be equal to y1 plus y2, right? You can also take u and v also, right? Here now, to reduce the exponents, I need to go for the logarithms. Applying log both sides to this, so that comes to log of y1 equals to log of sin x, here sin x raised to the power of log x, right? Now here log of y1 equals to, this power comes front, so that is log x multiplied by log of sin x. Yes, log of sin x, log x comes here, right? Now we will differentiate with respect to x, differentiating with respect to x. So this is log of y1, so it becomes 1 upon y1 differentiation, and since the function is not in x, it is in y1, so again we need to differentiate dy1 by dx equals to, this function is in the form of u and v product. So that's why I haven't taken the first function as u and v. That will be getting confused with this, right? So this is u and v product function. So that means let us write u, first u, then v dash. Either ways you can do, because there is a plus symbol, u v dash or v u dash, anything. So u v dash is log of sin x differentiation, that comes to 1 upon sin x, and again according to the chain rule we should differentiate sin x. Sin x differentiation is cos x, so let me write here 1 into cos x, okay, plus, now we will keep v as it is, log of sin x, then we will differentiate u log x, that is 1 upon x simply, right? Here we have 1 by y1 dy1 over dx is equal to, so we will simplify further, log x, this becomes cot x plus log x sin x, log of sin x, not log x, log of sin x by over x. So this y1 also I can bring it to the other side, so that becomes y1 into log x cot x, log x cot x plus log of sin x over x, okay. So y1 is what we assumed y1 as, sin of log x, so that we will write sin x, sin x raised to the power of log x is our y1, so that is log x cot x plus log of sin x over x. So this is dy1 upon dx. Now we will differentiate y2. First we will write the logarithms, then we will differentiate. Here, if I take a straight line like this, here y2 equals to x sin x. So taking logarithms to reduce the exponent. So that comes to log of y2 is equal to log of x raised to the power of sin x. So this comes front. So log of y2 is equal to sin x multiplied by sin x log x. Okay. So x here, this comes front. Now again we have u and v functions. Two functions we will differentiate with respect to x. Differentiating with respect to x, we have similar way 1 upon y2 according to chain rule dy y2 by dx is equal to. Now we will apply the uv, that is the product rule. This is u. Let me take u sin x as it is, and differentiation of log x is 1 upon x plus u as it is log x as it is, and differentiation of sin x is cos x. Now the similar way y2 dy2 by dx, I'll shift this y2 to the other side and we will simplify here. There is nothing to simplify here. Sin x by plus log x and into cos x. Right. Here y2, what is y2? dy2 by, this is y2 here. X raised to the power of sin x. This sin x by x plus log x. So here there is no simplifications. We don't need to do the LCMs and all that. You can keep as it is. So this is dy1 and this is dy2. So what is our y? So we have our y as this, isn't it? So dy by dx is equal to dy2. Just addition, differentiation of y1 here and y2 over. Yes, that means I want dy by dx. So dy by dx is equal to, simply I will add these two, this part and that part. So sin x raised to the power of log x sin x whole to the power of log x multiplied by log x cot x plus we have log of sin x by x plus we have plus this one, that is x raised to the power of sin x, here sin x over x plus log of cos x, log x cos x, not log of cos x, log x cos x. This is log of sin x. Okay, so this is the final answer. Please pause it and note it down. And here now moving on to the next problem. So let me congratulate the students who had given right answers for the DIY questions which I had posted in the which I had mentioned in the first video lesson of the differentiation, the introductory part. So those DIY questions, two of the students, I congratulate them. Their names are T. Pavan Kumar and Vaishnavi Naidu. Congratulations both of you. You have done a great job, right? Now do answer the DIY questions which I will be posting in between. So you will be named in my next video, right? Pause it and note it down. Let's move to the next problem. The third problem here, the second and the fourth bits you do for yourself, practice it. It is in the same way, in the same fashion, okay? So here again two functions with an addition sign. We will suppose this as y and this first function as y1, this as y2. So this they sum up to y. Okay, let y1 equal to sin x raised to the power of x, y2 equal to x raised to the power of sin x. So this is y1 plus y2 is equal to y. So what we will do, let us take y1 first, sin x raised to the power of x. Okay, so again we will go for log, both sides applying log of sin x raised to the power of x. So that comes to log of y1 equal to x. Here log some function raised to the power of x. So this only x comes out here. Log of sin x, log of sin x, right? Here sin raised to the power of x, this power, if you want to get it, you will be applying log. So only x comes front because this is the exponent. X log of sin x. Now again we have u and v, two functions in the product form. So differentiating with respect to x. So that comes to 1 upon y1 dy1 by dx is equal to uv function. So u as it is and v dash. So log function, so it comes to 1 upon sin x. Again this is not a x function, just not an x, it is sin x. So we should do sin x differentiation according to the chain rule. Differentiation of sin x is cos x. So I'll write it above. And plus log of, that is u, that is v multiplied by u dash. X differentiation is dx upon dx is just 1. So that means here x cot x plus log of sin x, right? So and we can also write this as y1. So I'm cross multiplying this y1 to that side. So this becomes dy1 upon dx. We will write what is y1 also. So what we supposed y1 as, this sin x raised to the power of x into x cot x plus log of sin x. So this is dy1 upon dx. Now we will take the y2 function here. So y2 equal to x raised to the power of sin x. Let's go for applying log both sides. Log of y2 is equal to log of x raised to the power of sin x. So this is the exponent power, so that comes front. So that is sin x log x. Okay, sin x log x. So this is log of y2. We will differentiate with respect to x. Let me write here differentiating with respect to x. So we'll differentiate here. That is 1 upon y2 dy2 by dx. Chain rule, right? Since the function is not in x. Now here u and v. So sin x as it is and derivative of log x is 1 upon x plus log x into derivative of sin x is cos x. Okay, uv and vu dash. Okay, now here dy2 upon dx is equal to y2 multiplied here sin x divided by x log x multiplied by cos x. Log x cos x we can say. Now y2 is what? y2 is our x raised to the power of sin x. X to the power of sin x multiplied by sin x by x plus log x cos x. So all these sums 1, 2, 3, 4 are in the same way. So that I have done 2 for you. You can do the other 2. Now here y is equal to y1 plus y2. So dy by dx is equal to dy1 dx plus dy2 by dx. So let's just write, just club these two. What do we got? dy1, that is, so dy upon dx is equal to sin x raised to the power of x multiplied by here x cot x plus log of sin x. Okay, x cot x plus log of sin x here plus here dy2 by dx, that is x raised to the power of sin x. So sin x by x plus log x sin x, log x cos x. Okay, so this is the final answer. Pause it and note it down. In the third section, the second bit here, establish the following. If the first one, x raised to the power of y plus y raised to the power of x is equal to a raised to the power of b, then dy upon dx is equal to this part we need to prove. Given if and then function, right? Here we have to start with this, we have to prove this one. Okay, we will suppose as usual this as y1 and this as y2. We don't have y here. We will be getting that y during the process, dy upon dx, because there is a y function here, right? So let y1 equal to x raised to the power of y and y2 equal to y raised to the power of x, right? So let me write y1 equal to x raised to the power of y. Now we will apply log here. Log of y1 equal to log of x raised to the power of y. So that comes to log of y1 equals to y log of x. Now we will differentiate with respect to x. So differentiating with respect to x. So that comes to 1 by y1 dy1 by dx is equal to again u and v function. Yes, here this function is y, okay, u and v. Now we will differentiate, we will write y function as it is and we will differentiate u, that is 1 by x, plus log of x, v function as it is, and differentiation of u. So that is dy by dx. Here we got dy by dx. So that means I'm not supposing this as y. This is a constant. This is not y function, right? Here y, dy upon dx we have already. We have to prove dy by dx is some other thing, right? So we will take this as 1 by let me write this y to the other side. dy1 by dx is equal to y1 if you shift this here. So this comes to y upon x plus log x dy by dx. Let us suppose this as equation 1. Let us keep it as it is, like equation 1. Now we will do the y2 function here. So applying log both sides, okay, log of y2 is equal to log of y raised to the power of x. This comes to log of y2 equals to x log y, okay, x log y, and here differentiating with respect to x, that comes to, let me do a partition here, okay. If you are differentiating with respect to x, that is 1 y2 dy2 by dx is equal to, now uv function, this is u and this is v. So x differentiation of log y is 1 by y. Again this is not y, so this is not x, so dy by dx we have to do chain rule, okay, plus we have log y and differentiation of x is just 1. So we will shift this y2 to the other side. So this becomes multiplication. So x by y dy by dx plus log y. Yes, and here we can also write, before writing this equation 1, we can also this we can substitute. y1 is just our x raised to the power of y, isn't it? So we will write this as equation 1. Similar way there also we'll write that. So this is equation 1 dy1 by dx, right? Here also y2 is what? It is y2 is y raised to the power of x, again x by y dy by dx plus log y, right? And here now this plus this, we need to add both. Let me suppose this as equation 2, okay. Here if you take the differentiation of this function, here we got this. So okay, we will be adding these two functions, and differentiation of this constant is 0, isn't it? What we are finding, we are supposing this as y1, this as y2. Differentiation of this function is dy1 by dx. Differentiation of this function is dy2 by dx, and differentiation of a raised to the power of b is, that is a constant, that is 0. So we can add these two and equal to 0. So that means let me write it here, dy1 plus dx plus dy2 by dx is equal to 0. Differentiation of a raised to the power of b is 0. So these two I can add them, equation 1 and equation 2. y by x plus log x dy upon dx plus this one, that is y raised to the power of x by y dy by dx plus log y. Now we can do some simplifications. This is equal to 0 we have. But we have to prove dy by dx is some other thing here. Right? That means let us simplify here. Here if you multiply, this comes to x raised to the power of y minus 1. See, y, x is there 1 here, okay? Into y plus, I am multiplying this, opening the bracket, x raised to the power of y log x dy upon dx plus, here the same way, y raised to the power of x minus 1, since y is here below, into x dy by dx plus, again this multiplied y raised to the power of x log y equals to 0. According to equation 1 and equation 2, I have added them, and here we will do further simplifications. We will bring dy by dx to one side, we will club them, the rest of these two to the other side. Okay, so that we will do it here. Let me suppose this is equation 2. Let me do this here. Here, dy by dx, we will take it to one side, dy by dx, so that I'll club it. Here, this becomes x raised to the power of y multiplied by log x plus, here plus, isn't it? Here, x into y raised to the power of x minus 1. X into y raised to the power of x minus 1. This is x raised to the power of y. These two are having dy by dx, so I have clubbed them, and the other two we will shift over to the other side. So since that there is 0 here, so if you are keeping is equal to, this becomes minus, because these two, I'll write it here, minus x raised to the y minus 1 multiplied by y, and this part is minus here y raised to the power of x multiplied by log y here, right? So that's what we got here. Yes, here, this over this y x raised, this part we got here. So if you take minus common, you'll get it. Okay, so dy upon dx is multiplied by xy log x plus xy x minus 1, this is the bracket, equals to, I'll take negative sign common, so this becomes, let me write here, let me interchange here, so y x y minus 1 minus plus yx log y, because I have taken negative sign outside. Now here, this multiplied by this, if you shifted the other side, it becomes divided. So the final answer is dy by dx is equal to this minus yx y minus 1 plus yx log y divided by this part, x raised to the power of y log x plus xy x minus 1. Okay, these two. So you can club them. There is a negative sign, you can write it. If there is a fraction, you can take it for the complete thing. You can write the final answer like this, minus, so yx y minus 1 plus yx log y, xy log x plus xy raised to the power of x minus 1. This is the final answer. So what we did, let me sum up here. So I've taken the first one as y1, the second one as y2, and this is a constant, right? Now here, taking that and applying log both sides and differentiating with respect to x, we get two equations. Now I am clubbing those two equations because we should add these two functions. These two functions are y1 and y2. So differentiation of both of them, I am adding. That means differentiation of the constant is 0. I am adding both of them, and finally dy by dx I am taking it out, so that the other terms I am shifting it to the other side. This becomes minus upon this one. So we have started with this function and we got this function. This is the final answer. Okay, like this questions, we have other questions. We will see to the other questions in our next class. Now till today we will end the class. Pause the video and note it down, and thank you all.